Alrighty, let's get started. Quick show of hands. Who has contributed to Rails before? Awesome. Who has contributed to any open source project? That's even better. Who hasn't but wants to? I'm glad you are all here. Thank you. Hopefully by the end of this, we'll have even more hands raised. My name is Hartley McGuire. I'm on the Rails triage team, and I'm a senior developer at Shopify, where I work on our database platform called KateSQL. If you have any questions about that, feel free to find me later. Today I'll be talking about how to upstream your code to Rails. We did a poll. A lot of you are already convinced that contributing to Rails and open source as a whole is a great idea, but just in case you want to learn why you should contribute, we'll start with that. The first reason why is that you can lower your maintenance costs. If the code is in your repo, you are ultimately responsible for it. You have to run tests, you have to fix bugs, and you have to make sure that your code works with your current and future versions of Rails. Hopefully you're not monkey patching or using undocumented APIs, but if you are, then you run the risk of anytime a Rails upgrade happens, those could break. If you are able to upstream that code to Rails, suddenly that responsibility becomes shared. Rails will test the code, Rails will ensure that the code works with new versions, and Rails can use its own undocumented APIs without worry. All of that leads to much easier upgrades for you, and you being able to focus on the important parts of your application, the application. One of my personal favorite reasons to contribute to Rails is to improve my knowledge of it. When upstreaming code, there are multiple different parts of the process which serve as fantastic learning opportunities for developers working with both Ruby and Rails. The first is that when you look at code you want to change, you will probably want to understand why that code was written the way it was. For this, I'm usually a very heavy user of git blame. If you haven't heard of git blame before, it's a command that you can run which will show you the history of changes for every single line in a file. And to be honest, the name of the command is a little deceiving. The goal of using git blame is just to gain context about why code is written the way it is. So I actually know many people who will add this little snippet to their git configuration to alias blame as context so that they can just run git context, and then they're not blaming anyone when they look up the context of the code. Personally, I'm actually not super familiar with the command line version. I will usually go through the GitHub UI, and this is what that looks like. You can toggle between the regular code view and the blame view up in the top left corner. The blame view adds this new column on the left, which shows you the commit that last changed a line of code, and it also gives you this little button to show you what the file looked like just before that commit. For example, if we click the icon with the arrow next to delay loading Zeitwerk at the bottom, it will then show you that the code used to look like this. What I really love about this is how much you can learn from reading through the commit messages and pull request discussions that lead to a code change. Speaking of pull request discussions, another huge learning opportunity when contributing to Rails is the feedback you can receive from pull request reviews. The reviewers will be some of the people most knowledgeable about Rails in the whole world, and there's a ton that you can learn from them. Another important reason to contribute to Rails is to be a good open source citizen. There are currently over 70 gems in the default lock file when you create a new Rails application. When combined all together, these libraries all work together to create the Rails framework experience that we all know and love. By contributing to Rails or any of these libraries, you aren't just helping yourself. You're giving back to all of the people behind these libraries who have enabled you to use Rails. You're giving back to the Rails community by making these libraries continue to provide users with the best possible experiences. And you're helping to ensure that the Rails community continues to grow and be a 100-year framework. Finally, the most fun reason to contribute to Rails is to collect internet points. You may have seen yesterday that the Rails team maintains this leaderboard which lists all the people who have ever contributed to Rails. The list even includes contributions from before Rails was hosted on GitHub. It was originally on Subversion. 6,000 people have contributed to Rails so far, and the number keeps going up. I think since I took this screenshot, I've seen over 30 new contributors in like the past couple weeks, which is amazing. And the best part is that any contribution you make will add you to this list, whether it's big or small. So now I can hear the questions coming in already. Wow, that leaderboard is so cool. What can get me there? I'm so glad you asked, because next up I will be talking about what to upstream to Rails. One of the smallest but most impactful things you can contribute is documentation updates. Are you reading the docs and find a typo? Could an idea be explained better? Any issues you may have with the docs are most likely happening to other people as well. If you take the time to make the documentation better, then you can help out every single person who comes to read it after you. And what makes these changes so impactful is how the quality of the documentation can shape a user's experience with Rails. If someone is trying out Rails for the first time, their very first impression of the framework will be the Getting Started guide. So it's very important that this guide, as well as the other guides, are well-written, typo-free, and easy to understand. If you're interested in improving any of the guides, there is even a guide that covers style and formatting guidelines for the guides. You can use this to make sure that you follow all of the best practices. In addition to the guides, which are more narrative and are in their own folder inside the Rails repository, the Rails documentation also includes API docs, which are generated from the documentation comments inside the Rails source code. The API docs are meant to be the definitive source of information for all of the documented methods in Rails. In this case, documented is the promise that the method won't change between Rails versions without deprecation, so they're safe for you to use. Just like the Getting Started guide is especially important for new users, the API docs are important for all users of Rails. If methods are not documented here or the documentation is poor, then people have a harder time working with Rails day to day. And just like there are guidelines for content in the guides, there's also guidelines that can help you if you're interested in contributing to the API docs. Next up on the list of things to contribute is bug fixes. There are effectively two ways that you can find bugs to fix. The most commonly discussed one would be finding a bug to fix on the issue tracker, but I'll be honest and say that can sometimes be a discouraging process. Since many companies run their Rails applications on the main branch, many of the smaller trivial bugs will be fixed relatively quickly and you won't have an opportunity to do that. That means the issues on GitHub will tend to be complicated and may not have obvious solutions. The way I've found that tends to be best is when you find bugs through using Rails in your day-to-day life. I found fixed a few bugs recently in the app that I work on. When we did our upgrade to Rails 7.04, we found a regression in migrations about types. So we wrote a fix and we opened a pull request. Once it was merged, we were able to update our gem file to point at Rails 7.0 stable branch so that we could get the fix immediately. Bug found to fixed, all within 2 days. And using the 7.0 stable branch has additional benefits as well. Dependabot knows how to update it, so if the branch receives new commits, we can still get them. This is especially important when it comes to security releases. If your app uses a forked version of Rails with your fix or any other patches, then you have to apply security fixes yourself. By using the 7.0 stable branch, we continue to receive these new commits without any of the additional effort. Certainly much less common than bug fixes are performance improvements. If you find something in Rails that could be performing better, send a pull request. Here's an example of a great performance improvement pull request from a few weeks ago. The most important thing to include in these pull requests is a benchmark to compare the original implementation with the new one. The benchmark code from this pull request is a little long to go through completely, but we can break it through in parts. The script starts out with an inline gem file. This is what lets other people run the script as a single file, and Bundler will ensure that all of the dependencies get installed. In this case, we only have 2 dependencies, Rails and benchmark IPS, which is a great library for measuring the relative performance of methods. And the inline gem file kind of looks hard to remember, and it is. So the Rails repository actually includes a benchmark template that includes this as well as other parts, and you can base your benchmark scripts off of that template. By the way, I will put a link to the slides at the end so you don't have to remember that link. The next part of the script is the new implementation of the method we want to benchmark. By naming the method something different than the original, it allows us to easily compare the performance of the two in a single file. And finally, we have the part that uses benchmark IPS to compare the performance of the original method and the new implementation. And if we run the script from that pull request, we will see that the new method is actually 6 times faster than the old one for a large database configuration. And finally, the last thing on my list of what to upstream is, of course, new features. One of my favorite parts of Rails is that many of its largest features began as successful pieces of Rails applications. These features are refined and battle-tested in production before eventually being adopted by Rails itself. Once upstreamed, the original authors can share the maintenance cost with the community, and the community benefits from being able to use the new feature. So now that we have a solid desire to contribute and a good idea of what to contribute, we can finally learn how to upstream your code to Rails. Let's do a feature. In the Rails application I work on, we have a validator called Immutable Validator. Its purpose is to prevent certain attributes from ever being changed. Let's start off by walking through how it works. Validate each is the entry point for an active model each validator. When a model adds a validation like this, then Rails will look up the immutable validator class, and it calls validate each, with the instance of the model being validated, the name of the attribute as a symbol, and the value of that attribute. Given all of that information, the immutable validator will need to check 2 things. The first is whether the record is persisted. If the record hasn't yet been saved, then we don't actually care if the value changes because it's just being set for the first time. The second thing to check is whether the attribute we want to be immutable has changed. If both of these things are true, that the record has been saved previously and an immutable attribute is being changed, then we add a validation error. And so far, we've been looking at a basic case where content is something like a text column on the post model. But what if we want to validate that an association doesn't change? Instead of validating content, let's validate a post's author. Our immutable validator handles this case for us as well. Instead of passing the attribute directly to attribute changed, we send it through this attribute name method, which we will write. If the attribute is one of the record's attributes, we just return it. It's just a column on the record. And if it's not one of the record's attributes, then we want the method to assume that the attribute is actually an association, and we'll look up its foreign key. So in the case of validating the author, instead of returning the symbol author and passing that to attribute changed, this method will return author ID. If you haven't seen some of these methods before, that's totally fine and actually expected because they are internal methods to Rails. All of these methods are currently undocumented, meaning that there's no guarantees about them not changing. When I saw this, it immediately set alarm bells off in my head. To remove these undocumented methods from our code base, we could either look for documented alternatives, or we could try to just upstream the validator. And you can probably guess which way I went. There are a few reasons I thought this would be a good candidate to upstream to Rails. In addition to the undocumented methods, active model and active record already come with a number of validators that are generally useful, and immutability kind of fits this theme of being generally useful. We have some other validators in our app that are more domain-specific to Kubernetes, and those things would not be upstreamable to Rails because they are not generally useful. In addition, Rails already has a very similar feature named attribute read-only, but it doesn't quite do what we want. Attribute read-only will prevent attributes from being updated in the database, but it does so silently. You can still update the attribute in memory and call save. It just doesn't actually save the value to the database, so it's kind of a foot gun and hard to understand. However, since the concept of read-only attributes already exists in Rails, that would probably be a better name for our validator. So to get it ready for a pull request, we will rename it to read-only validator. In addition, we'll put it under the active record validations namespace, since that is where the existing validations in active record are. And we can also move the attribute name method to be private because it shouldn't really be called by other methods. Now that the validator is ready, we can go ahead and commit it and open a pull request. When we do that, we'll see this wall of text in the top of the pull request template. For the purpose of this talk, I'm going to skip over it, but you should probably read it if you make a pull request yourself. The first section to fill out in the template is the motivation for creating a pull request. As the comment mentions, it can be a good idea to reference GitHub issues here, and I also like to mention other pull requests or commits if they can provide additional context. Let's write the background for this change. In this case, there are not any GitHub issues to link, so we will just describe why the existing attribute read-only feature does not quite do what we want. The next section is the description of what the pull request is. A common mistake I have seen is that a lot of people will put what files they changed here, but that's not really what we want. What we really want is the what and the why for the changes being made. Let's fill out this section too. Here we include a description of what the code is, why it's better than the existing attribute read-only, and an example of how to use it. In addition, I've added a co-authored by line at the bottom. For the original author of the code, I'm upstreaming, which will give them credit for the commit both in GitHub and on the Rails contributor website. As a side note, I actually prefer including all of this information in the commit message itself, so let's update that too. We can amend the commit with the updated information. By writing commit messages this way, it prevents future people from reading the commit from having to click into pull requests to get all of the context. And because the commit message is intentionally written in the format of the pull request template, when I go to open a pull request, you can just copy all the places straight into the template, which is very nice. So going back to the template now, there are 2 more sections. For this pull request, we don't have any additional information to add, so we can leave that blank. The last section to look at is the checklist. Let's look at each one. Is the pull request only related to one change? We don't want to include refactors or other things that are unrelated to the one thing we want the pull request to be for. In this case, yes. All we do is add the validator, and that's it. We aren't doing anything else. Is the commit message detailed? Yes, it is. We amended our initial commit message with a detailed description of the change, including the motivation. Did we add tests? We did not. Let's add some. We can use the existing immutable validator tests that we have in our app, and with a few tweaks to the models to make it work in the Rails tests, and obviously we have to rename it because we renamed the validator. Boom, test added. Finally, did we update the changelog for our new feature? We did not. We can add this to the top of the active record changelog and update the commit again. And now we've checked off everything in the list, and we can submit the pull request. And now we wait. Sometimes it can take a bit for people to provide feedback on your pull request. In this case, I was actually pretty lucky and got feedback the same day I submitted it. The bad news is that it looks like this pull request won't be accepted as is. However, this feedback was awesome for me as I learned something new. The distinction between user and developer errors was not something I'd really considered when writing validators before, but now I will think about it a lot when I write validators in the future. In addition, Raphael gave a suggestion for a different direction to go so that we can just get the behavior we want in Rails, even if it's not through this approach. What's even better is that someone had already done something like this before. This pull request was opened a few years ago to try to address one of those weird quirks about attribute read-only. It proposed making the attribute assignment do nothing instead of allowing it to work just in memory and then not save it to the database. And this is the proposed approach. There is a lot of code here, so let's break it down. This attribute read-only method is a class method that you call in your model when you want to mark attributes as read-only. It works similar to associations. The important bit to notice is that calling this method now redefines the read-only attribute setter so that when you call it, it will only update the attribute if the record is new. We can use this same technique, but take it a step further by having it raise if the record is new. And that will look something like this. For the most part, the code is same, but there are a few additions. The most important addition is that now we make the method redefinition optional. This ensures that anyone using attribute read-only right now doesn't have any breaking changes, and it will behave just the same as it does today. You have to opt into the configuration. Another change is that we are now raising an error instead of doing nothing when the record is being updated. And finally, we now include this has read-only attributes module into the class when it calls attribute read-only. And that module looks like this. This is necessary because redefining the attribute setter only works for this first type of assignment. None of the other methods go through the attribute setter. The good news is that they do all use the same underlying method to update attributes, which is called writeAttribute. So by including this module in the class, we can override the writeAttribute method and raise an error if the attribute is being updated but is supposed to be read-only. And this ensures that all of these different ways to try to update an attribute all behave consistently. Next, we'll add some tests for all of these different ways to assign attributes. Please don't try to read this. I just want to emphasize how many there are. And we'll also add a changelog entry, again, including the author of the original pull request we based the change on. And then we can commit all of these changes, write a detailed commit message, including the motivation for the change and some additional details explaining some other things that were related that we had to fix around some tests that I'm not including here because they're complicated. And this time, since there was prior work, let's link to it in the additional information section. In addition to linking the pull request we used as a reference, we'll also add a closes line for our first pull request so that it will be closed if this one gets merged. Then we can go through the checklist. This pull request is still only one change. The commit message is detailed. We included tests, and we updated the changelog. Perfect. Let's submit this. And now we wait for feedback again. Unfortunately, this time it doesn't come as quickly, and this is totally fine. You should not be discouraged if a review doesn't come immediately. The maintainers don't have unlimited time to review pull requests, so sometimes it may take some time to get a review. And sometimes no feedback can actually be better than getting some feedback. If a reviewer sees something wrong with the pull request, like in the case of the first one, they may be more likely to comment and say something negative than they will if they don't see anything wrong and just want to hear other opinions. If your pull request has gone a few weeks without any feedback, the best way to get attention would be to bring it up on the contributor Discord. This server's purpose is specifically to discuss contributing to Rails and was created to help people get feedback on their contributions. In this case, it ended up taking a few months, but the pull request was merged. We did it. Everything's great. Well, until the next week, I get a Slack notification. As Raphael mentioned in his keynote yesterday, sometimes having a huge monolith running on Rails main means that we find regressions in the monolith test suite and not in Rails. And that is what happened here. In our monolith, we started seeing this failing error when we tried to upgrade to Rails main. Somehow, the attribute setter we redefined was unable to call super because there was no super method to call. Okay, back to the drawing board for a bit. We originally tried to redefine the attribute setter because that was the method we wanted to make read-only. But now, because of the dynamic nature of when attributes are defined, it seems like this strategy might not work. The good news is that attribute setters actually all end up calling a method similar to the writeAttribute method we redefined before. We can add this specialized writeAttribute method to the included module as well. I tested this change against our monolith, and the failing tests now pass. Awesome. However, now came the harder part. I needed to create a failing test for the Rails test suite. And at this point, I was a bit stuck, because I could see that the issue had something to do with inheritance, but I couldn't quite pin down what the problem was. Attribute read-only was being called on a superclass, and its subclass was the one throwing an error. I tried writing a test that used a subclass of a model with a read-only attribute, but this test did not fail. At this point, I was kind of stumped. Luckily for me, some coworkers jumped in and provided me with the answer and a test case to go along with my fix. The reason our test was failing was that the model was not just a subclass, but a subclass of an abstract class. The setter redefinition worked in the regular inheritance case because the attribute setter was still being defined on the superclass before attribute read-only is called. But this doesn't work when the superclass is abstract because abstract classes don't have attribute setters defined on them. Now that we have a test case that fails without our change and passes with it, we can create another pull request. Once again, we will write a detailed commit message where we describe the problem how our changes fix the problem, and add co-authored by lines for the people that helped us write the code. Then in the pull request template, we can use our commit message for the first 2 sections, and under additional information, we'll add the issue that we want to close. And then once again, we'll go through the checklist. This pull request only relates to one change. The commit message is detailed. The related issue is linked, and a test is added to prevent regressions. Since this is a bug fix for a currently unreleased feature, we actually do not need to include a changelog entry for it, because changelog entries are only for changes from released versions. And once submitted, the pull request was merged, and our monolith was able to continue with its weekly Rails upgrade. And now we're done for real this time. Our feature is upstreamed, we found and fixed a bug, and the new and improved attribute read-only will be available in the next major Rails release. When that time comes, we'll be able to delete the immutable validator from our app to reduce our maintenance cost and replace it with the Rails native version. I hope everyone has learned something new and can now confidently say that they understand the process to upstream their code to Rails. Hopefully, I will see you all on the GitHub repo soon. Thank you, and that's the link to my slides.